Welcome to an information session dealing with electrical and computer engineering technical elective courses and the Accelerated Master's program at the University of Arizona. As you're looking forward in taking your technical elective courses here at the University of Arizona, you might look to be as broad as possible because you really don't know what you're going to be doing in 10 years and 20 years. And to help you in that selection process of your elective courses, you might look at how we've tried to lay out our course numbering, and it's consistent with what you've already taken as freshmen and sophomores here in terms of what decade particular classes might fall into, and take this a little bit loosely because we've run out of numbers, and so we've had to introduce courses with numbers that maybe aren't as consistent with this numbering strategy as we would like. But if you enjoyed classes that were in the 20s, like 220, 320, the 40s, 340, those are signals and systems classes, and technical elective courses in signal processing, in communications, and in control will fall in generally the 20s, 30s, and 40s, meaning 429 is a digital signal processing class, 441A is a controls class, etc. If you enjoyed 351, electronics, then you might look at classes in the 50s. Decade-wise, if you enjoyed computer-related classes, 175, 274, 369, those classes then in the computer area will be mostly focused in the 60s and 70s decade, and 479 is artificial intelligence, etc. Likewise, for electromagnetics, you'll find those in the decade of the 80s. If you want to get a little bit more information about the different classes, you can go to our website, the ECE website, and click down on courses, and you should be brought to this particular site, and this now gives you a syllabus, a brief syllabus for a particular class, one such class being ECE 330B. And at this location, you'll be able to find textbooks, learning outcomes for the class, and class topics relative to that particular class. As you will see, you will maybe want to broaden your perspective. In addition to 400 level or senior level classes, you might be interested in taking graduate level courses. And again, you can find those course syllabi by looking under our grad programs courses link, and that will take you here. And now you can look at, for example, web development and the Internet of Things being a dual numbered class, 413, 513. If you are in the Accelerated Master's program, you could take 500 level classes that will count towards both your undergraduate degree and your graduate degree. And you could potentially then take ECE 513 in the 500 version and apply that to both your undergraduate BS degree and your graduate MS degree. In addition to, if you do want to take, so those syllabi will include textbook information, description of the course, topics, prerequisites relative to what you need to have already taken before you get to that class. If you are going to be taking graduate level courses as an undergrad, you will need to submit a form, and you can find that form by searching at the main arizona.edu website under undergraduate enrollment and graduate course. And if you want the course descriptions for different classes, you can go to the catalog.arizona.edu I've now made that available, and here you could search for different classes. Here I've searched for 330, which is computational techniques. This gives you now the course description associated with that particular class. And if you're interested in numerical integration, numerical differentiation, numerical optimization, solving differential equations, ECE 330B is a class that you would be interested in taking as a technical elective. And if you want to learn a little bit more about the faculty that might be teaching those classes, we do have faculty videos on our website. Here's the direct link, and you could then find out a little bit more information about the instructor that you now maybe have assigned to the classes that you've signed up for. Let's now look to the best of our ability right now in terms of planning. And again, depending on faculty members, leave of absence, sabbaticals, research activities, some of these classes and availabilities may change. I apologize for that, but right now, as of today, this is what we're thinking will be available for the spring semester of 2023. Here is one, and let's just talk about those relative to the different sub areas in electrical and computer engineering. Maybe computer courses to start with. You have ECE 330B. We already looked at that course description. That's computational techniques. If you're interested in machine learning, we're actually going to have a couple of machine learning classes being offered in the spring semester, ECE 523. And again, I'm going to give you 500 level and maybe even 600 level classes, because many of you will be able to take 500 level classes as an undergraduate student. And some of those are 500 level only. Some of those are dual numbered. That's okay. If you want to take a graduate level class, you can take the 500. If you don't want to take that, then ECE 523 would not be available to you, but you could take 462, which is computer architecture, which is now a extension or a step up beyond ECE 369A. How do you make your computers that you're now building even better than what you were able to do in 369A? Relative to enhancing the performance of computer systems, this spring you have the availability of taking high performance computing, which is ECE 569. Now, how do you do parallel processing, work with those high performance features of computing, and understand the foundation behind that? 471, 571, fundamentals of information and network security. Again, if you have access to the course descriptions, which you will have available to you through the U of A website, you can now look at these very quickly and see that 471 is big on cryptography, different kinds. You have symmetric key cryptography, cryptographic hash functions, authentication, essentially wireless and network security. That's 471, 571. If you're interested in AI, artificial intelligence, that's available to you as 479, 579. Again, you can search for that and have this information. If you want to know how are games built, how do we do robotic planning, expert systems, that's the kind of information that you will be learning in 479, 579. Moving on to a different category of courses, the electronics and biomedical related classes, ECE 304A, that's a follow-on to ECE 351C. If you liked 351C, that was the first half of the textbook. The second half now in combining these different pieces of a preamplifier, power amplifier, etc., putting all of those together, now ECE 304A is where that happens, and there's a lab component to 304A. If you are a computer engineering student in that track, you can take ECE 352, device electronics. That tells you the underlying physics. How do these devices actually function or work from a physics perspective? ECE 407, 507. Again, this could have been maybe included in the computer area. This is digital VLSI. How do you do very large scale integrated system design? How do you implement these logical functions in hardware? How do you build those, and what kinds of decisions do you have to make if you actually want to understand how to build or do the processing necessary for semiconductors? Then you would want to be taking ECE 446, 546. In the electromagnetics and optics course area, there's introductory electromagnetics. Again, this is a required course in the EE option, but for those computer engineering students, they can now take this as a technical elective if you want to better understand wave propagation. How do these wireless devices physically work? Now you can use your Calculus 3, your vector calculus to better understand electromagnetics and wave propagation. A mathematical-based course relative to understanding optics and photonics, that's 403, 503A. If you're interested in photovoltaics, solar energy, how do you make these devices more efficient, effective? What goes into solar panel construction? That's 414A. A photonics communication lab. And another class dealing with wireless is antennas. How do we keep making these devices capable of communicating, even though the footprint or the scale size is getting smaller and smaller? How do we make these antenna function as effectively as they are? And that's 484, 584. In the signals and systems area, this spring semester, ECE 532, digital image analysis. Again, you can go back here and search on 532. That's not a dual numbered class, but now if you're seeing these images, can you extract features from those or detect boundaries? Can you segment the image? Or what can you do relative to optical flow or mathematical morphology? And if those terms don't really mean that much to you, now you could go check out the syllabus and even email the instructor and determine if that's a class that you would like to take. And this class obviously has a prerequisite of ECE 340, but it probably would be beneficial to have already taken the digital signal processing class as well. 435, 535A, digital communications. That's now the first class beyond 340A. Now you're looking at the digital communications landscape and what's involved when you do start communicating digitally. Similarly, digital control systems. If you're wanting to know how do you change the dynamic behavior of a given system, or how do you make it behave better, now you can do that with a computer, a microcontroller. You can code that up and now merge that with a physical system to make the overall closed loop system better behaving relative to your design specifications. As I said earlier, we're offering a couple of classes in machine learning. Obviously, you might want to already have taken 523, but you might be able to take both of those in the spring semester. This particular class is advanced topics in machine learning, and you might want to then talk to the instructor, Dr. Tandon, to see if you could make that work in terms of what your foundational coursework looks like moving into advanced topics in machine learning. How do you now do gradient-based optimization strategies? How do you learn from data? How do you extract information from data? That's what you're going to get into in machine learning. As you're planning your spring semester, obviously you won't be able to take every one of those technical elective courses. And this weekly schedule helps illustrate how certain classes actually conflict schedule-wise. So here you can see that you would not be able to take ECE 304A, the follow-on or second semester electronics course, if you were also wanting to take the computer architecture class 462, 562. Those are both offered from 9 to 9:50 on Monday, Wednesday, Friday. So what you would want to do is look at this particular layout of the weekly schedule and correlate that with what you're interested in taking, and then find particular classes that don't overlap and allow you then to take the classes that you're wanting for your elective coursework. And you can see that we're trying to fill in most of the spaces, and because most of the students taking their technical electives are senior students, then we're leaving really sort of these Tuesdays and Thursdays time windows open for your engineering capstone. In the fall, what we are anticipating based on what we know right now relative to sabbaticals and leaves for faculty, these are the classes. In the spring semester, we offer the core courses in the electrical engineering foundation. In the fall, we offer the computer related. And so here you see EE option students can take fundamentals of computer architecture 369A, or they could learn more object-oriented software design in ECE 373. There's also a class on web development and Internet of Things 413, 513. Computer networks, how do you put networks of computers together? Cybersecurity, how do you make that happen from the concept all the way through to practice? In the bioelectronics area, we have 415, 515, microelectronic manufacturing and the environment. 434, this is now how do you, or it allows you to better understand the electrical and optical properties of materials. What can you now put together and understand from an electrical and optical perspective? Analog integrated circuits, hopefully we'll be able to offer that. That's 450, 550 in the fall semester. In the electromagnetics area, we have passive circuit designs. That's now in the microwave frequency region. How do you design filters, different systems dealing in the microwave frequency interval? Holography and diffractive optics. And if you really enjoyed 381A, now you can step it up a notch and look at electromagnetic field theory at the graduate level at 581A. In the signals and systems area, these are the 20s, 30s, and 40s roughly. You have digital signal processing, optical communication systems, automatic control systems, and then we have more specific 500 level courses, advanced linear systems theory. What math do you need to work on? Quantum systems, control theory, communications, that's available to you as ECE 501B, advanced linear systems theory. Probability and random processes, that's very important for moving forward in your graduate education and even in your future career as an electrical and computer engineering, knowing and understanding random processes and how that influences or is impacting your particular systems. Digital communications 2 is 537, and radar signal processing. How do you now maybe better integrate into this environment of autonomous systems? How does radar work? How do we use that? And what kinds of processing are available to us when we're dealing with radar signals? Something that you might keep in mind, hopefully maybe we have some juniors watching this. If you are, and you're interested in entrepreneurship opportunities, you'll want to take advantage of those in your junior year, because these particular classes, this 1-year sequence, 2 semesters, Entrepreneurship 487, Entrepreneurship 484, are offered or are available to ECE students, but those 2 classes actually conflict with, right now, the scheduling of the engineering capstone on Tuesdays and Thursdays afternoons. So if you want to do this entrepreneurship, then I would suggest you fit it into your junior year, and these 2 classes will be allowed as your non-ECE technical elective courses. And this allows you to go from some idea or concept, understanding, okay, is the market going to be open to this particular idea? How do we understand the market? And how do we put together a business plan, integrating all of the different features financially, operationally, and marketing? Those are what you learn, and you really do this 1-year sequence that allows you to go from concept all the way through to possibly creating a viable business. Here is the weekly schedule for the fall. Again, this is tentative, but you can see how you might want to plan or think about these decisions if you have to decide between one or the other of these classes because of the overlapping nature of the weekly schedule. That's the technical elective information, but as you're going through your undergraduate degree, hopefully you've heard about the Accelerated Master's Program. This is very effective. It allows you now to obtain not only a bachelor's degree, a Bachelor of Science in Electrical and Computer Engineering, but also your master's degree in as few as 5 years. And this is available to our top undergraduate students. What it does is it allows you to count 4 of your technical elective courses, if you take those at the 500 level in your undergraduate degree program. You can count those towards your undergraduate degree program. Here in orange, you can see those courses, and then in your 5th year, that now allows you to only have to take 6 more classes to complete, if you were doing the non-thesis option, a 10-course, 3-unit each degree program to obtain your master's degree. And that's now an additional 30 units, but you can now count these 4 classes that you took during your senior year as a part of not only your BS, but also your MS degree program. If you're interested in the AMP, you need to be thinking about that very seriously as a junior. You need to have a cumulative GPA of 3.3. The GRE, the graduate record exam, is waived in terms of your admission to the MS program. You can submit your application to the graduate college when you have 75 undergraduate credits. You can start taking these graduate level classes once you become a senior, which means you now have 90+ units. And if you do have questions, you can contact Tammy Whalen at this particular email address. Again, just as a reminder, if you're interested in taking graduate classes, you need to make sure that you are filling out the appropriate forms. If you wanted to look at course descriptions, you can find the course catalog through the main University of Arizona website. You could browse the catalog, click on E for electrical and computer engineering. Once you get that, now you can find that entire description in PDF form by viewing all course descriptions. And if you want to see a syllabus, which includes not only the course descriptions, but the topics and an outline, the student learning outcomes, and faculty videos, here are the links for those. I hope that this gives you a little bit better picture of what you can now take as you move forward after you've completed your core coursework and are moving into the technical elective choices in your degree program. Good luck with your course selection and your progress through your BS and potentially MS degree program here at the University of Arizona.